Hi everybody, welcome to the last video of Chapter 7. This is Day 11, Section 7.3, Graphing Square Root and Cube Root Functions. So we're going to end the chapter with a little bit of graphing, okay? So what I want us to do first is let's go ahead and zoom in on square root functions and see what these look like first before we move on to cube root functions. So the first thing we're going to do is look at the parent function y equals the square root of x, okay? And what this does is it's going to start at the point 0, 0, and it'll pass through the point 1, 1, and then pass through the point 4, 2, and it'll look something like this, okay? So there are a little bit of things that we need to address. And that point there, that's called the endpoint. Okay, you'll hear us use that notation. All right, that's our endpoint, and that's pretty much the important point when we're graphing square root functions. All right, so let's talk about the general equation of a square root function. So we're going to be looking at y is equal to this a value times the square root of x minus our h value plus k. All right, so we're bringing back h and k and an a value, so all of these should look somewhat familiar to us. All right, now the key with square root functions is our endpoint is that hk value. All right, so h comma k. If we were to look at our general or our parent function over here, notice that there is no h and there is no k. Our endpoint is 0, 0. Okay, now when a is bigger than 0, we can say that the graph is going to open up. Okay, and we say up in parentheses because it kind of, it doesn't just go straight up, it curves out. If a is less than 0, it's going to reflect about the x-axis, so it's going to open down. All right, then the last thing we really need to talk about with square root functions is the domain and the range, okay? So the domain of a square root function is based off of our h value. So what we're going to do is we are going to compare the graph to our h value, okay? So we're either going to get x is greater than or equal to h, or it'll be x is less than or equal to h, depending if our graph is to the right or to the left of our endpoint. Okay? Then the range of our square root function is going to be compared to our k value. So we compare our graph to k. All right, so what this means is our range will either be y is greater than or equal to k if it opens up, or y is less than or equal to k if it opens down. Okay, so what I want to do before we talk about cube root functions is let's go ahead to our first example down below. So let's go ahead and zoom down a little bit. Okay, when we're graphing these square root functions. All right, so the first thing we need to do in example 1 here, all right, so we want to graph y equals the square root of x minus 1 plus 3. The first thing we need to do is identify our endpoint. Okay, so we're going to create our table of values, x comma y, and identify our HK values. So what I do is I look at the value underneath the radical, x minus 1. I essentially set that equal to 0 to get my h value of 1. Okay? The k value is the value outside of that square root, so it's a 3. So our endpoint is 1 comma 3. That point goes at the very top of our table of values. So that is our endpoint. Okay, now the trick with square root functions is I want to choose values for my table such that when I plug it in for x, I get a perfect square underneath our radical. Okay, so I do a little side note here. And I say, okay, well, my h value is when I would get a 0 underneath my radical. We can take the square root of 0. Okay, we cannot take the square root of negative numbers. So I need to look for my perfect squares. So my next perfect square I would come to is a 1. So what value of x can I plug into our radicand such that when I subtract 1 from it, I get 1, and we should recognize that if I plug 2 in for x, 2 minus 1 is 1. Okay? When I plug that in, I'm going to get 4 for y. Okay? The next perfect square that I want to try and get is a 4. Okay? 4 is the next perfect square we come across. So what value of x can I plug in such that when I take the square root of it, or when I subtract 1, I can take the square root of it. Okay, so x minus 1 is going to give me 4. That means x has to be 5. Okay, so when we plug this in for x, 5 minus 1 is 4. The square root of 4 is 2. Add 3. We're going to get 5 for our y value. Okay, so the reason I'm choosing these points here is because after I plug them in for x, I can take the square root very easily and get nice points. Okay, so I always make my side note off on the side to give me a little reminder of what values I need for x. Okay, so now we're just ready to go ahead and plot these points in our graph. So I always start with my endpoint. So we have the endpoint of 1, 3, and then we have 2, 4, and 5, 5. Okay, and I follow the direction of my other points. It's called an endpoint for a reason. I never, ever, ever go to the other direction of it. Okay, so the last thing now we have to do, we've got our graph, we need to state our domain and range. Okay, now remember, domain is the x values. So x compared to our h value of 1. Okay, now is our graph opening to the right or to the left of our endpoint? All right, and what we should notice is we are opening to the right. So our domain, our x values, are going to be bigger than or equal to 1. Okay? Now our range, remember, are the y values, and we compare the y values to our k value, which is 3. So what we need to ask ourselves is, from our endpoint, are we above that point or are we below for our graph? And we should notice that we are above, so our range is y is greater than or equal to 3. Okay? So there is our square root function. All right? So let's move on and go talk about the cube root function and see what's a little bit different about it. So now we're going to zoom back up here to the right and going to go through the example of our cube root functions. Okay, so the first thing we'll do is let's take a look at our parent function of y equals the cubed root of x. Okay, so I'm going to zoom in a little bit more so we can get a good look to the graph. Now, I am going to pass through the point 0, 0. Okay, we'll pass through the point 1, 1, and we will pass through the point 8, 2. Now, with cube root functions, I can take the cube root of a negative value. So I also am going to plot the point -1, -1, and -8, -2. So a cube root function kind of looks like this snake that changes directions and looks something like this. Okay, so this point here in the middle is no longer an end point. I call that a little blip. Okay, so that's the verbiage I will be using. It's not a very technical term, but it's basically the change of direction, okay, of our graph. So if we are going to look at the general equation of a cube root function, it looks very similar to the square root function. All right, so it's y is equal to a times the cubed root of x minus h plus k. All right, so that h and k value comes up again, only this time it represents our little blip. Okay, the change in direction is h comma k. All right, and now similar to the square root function, our a value represents something. So if a is bigger than 0, we are going to open up to the right as well as down left. Kind of like the picture over here. Okay, if a is less than 0, we simply flip across the x-axis. So we are going to open left, or sorry, we are going to, all right, let's try this again. We are going to open down and to the right, and then up to the left. Okay? The nice thing about cube root functions is our domain and range. Okay? So if you take a look at that graph, domain, are there any walls we can build that contain our graph? The answer is no. Our domain is all reals. For our range, is there a floor and a ceiling that we can use to contain our graph? Nope. So our range is all reals. This is always going to be the case. Okay, so domain and range of cube root functions, nice and easy to remember, but of course you can always look at your graph to distinguish this. Okay, so now let's go below and take a look at example 2. The first thing I want to do is actually change what example 2 is. All right, so let's zoom in on the equation really quickly, and I want us to change it. So I want us to graph y is equal to the cubed root of x plus 2 plus 1. So we're going to change that guy. It'll fit a little bit nicer on our grid. Okay? Now, as you see in the directions, we need to state and graph 5 exact points. Okay? We need to make sure we have a good shape to the graph. If we only do 3 points, we'll be missing out on those extensions, and we won't get a good, nice snake look to the graph. All right? So as we're creating our table of values, I look for my HK value again. Okay, so if you need to look back up to determine what that is. Okay, only this time our HK value doesn't go at the top of our table, it's going to go in the middle. Alright, so our H value is what makes underneath the radical 0. So X or H is -2. Our K value, we keep whatever is on the outside. So our H and K value here is -2, +1. That is our little blip. It goes smack dab in the table or in the middle of our table. Okay, that's going to remind us to get enough points that surround it. Okay, now similar to square root functions, I want to choose values of x that are going to give me a perfect cube underneath the radical. Okay, so this blip is when I get a 0 underneath the radical. The cubed root of 0 is going to be 0, so I can do that and then find my y value nicely. Okay, what's the next perfect cube we come across? Well, the next perfect cube I'd want to figure out for is 1, when I get a 1 underneath my radical. Alright, and then the next perfect cube we come across is going to be 2 cubed, which is 8. So I want to get an 8 underneath that radical. Okay, but remember, we can take the cube root of negative values. So I also have to think of -1 and -8. Okay, so these are the values that I'm going to try, to get underneath my radical. Alright, so what value of x do I need so that when I plug it in, I'm going to get a 1 underneath the radical? Well, we should recognize that if I plug -1 in for x, I will get -1 plus 2. Okay, -1 plus 2 is going to give me 1. The cubed root of 1 is 1, and then I add 1 to the outside. I will get 2 for y. Okay, when I plug 6 in for x, 6 plus 2 is 8. The cubed root of 8 is 2 plus 1. I will get 3. Alright, when I plug in, -3 for x, when I add 2 to that, I will get -1 underneath the radical. The cubed root of -1 is -1. Add 1 to that, I will get 0. And then finally, in order to get -8 underneath the radical, -8 plus 2, -10 plus 2 is going to give me -8. The cubed root of -8 is -2. Add 1 to that, I get -1. Okay, so now we're ready to go ahead, plot these points. So let's see what this looks like. I always start with my blip at -2, 1. And then we have -1, 2, and 6, 3. And then we have -3, 0, and -10, -1. So if we do this correctly, we'll get a nice shape to our cube root function. And there we have it. The last step we need to take is stating the domain and range. And our domain and range will always be all reals. Okay, so let's go ahead on to the next page. You can try some on your own. Okay, so what I want you to do now is pause the video, and I want you to graph these two functions. Okay, square root and then a cube root function. After you attempt these, come on back and we'll see how you did. Okay, so hopefully you had a chance to graph these. This is what you should have gotten. The key with both of these is there was a negative coefficient. So your a value was negative this time, so it reflects across this x-axis, meaning The square root function then opens down, and the cube root function opens down to the right and up to the left. Okay? If you have any questions with graphing square root or cube root functions, make sure you ask your teacher tomorrow. Have a nice night. Bye.